Something is happening in the void of space, a silent, imperceptible shift that has sent a ripple of urgency through every space agency on the planet. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, has just delivered a data set so profound it has rewritten the future in a single, silent transmission. The third interstellar visitor ever confirmed, the object known as 3/ATLAS, a wanderer from the abyss between stars, has done the impossible. It has changed its course. Not a gentle nudge from solar winds or the subtle drift of outgassing, but a deliberate, calculated, and sustained maneuver that defies the fundamental laws of celestial mechanics. For the first time in human history, the International Asteroid Warning Network, a United Nations-endorsed global coalition designed to protect our world, has trained its entire arsenal not on a local asteroid, but on a guest from another star, and the reason is as simple as it is terrifying. 3I/ATLAS is no longer heading out. New trajectory models confirmed by Webb's unparalleled infrared gaze indicate a new unsettling vector. It is now on a path that brings it toward the inner solar system, a path that, in several years, will intersect with our own. This is not a drill. This is a paradigm shift unfolding in real time. The International Asteroid Warning Network, or IAWN, was created for one singular, sobering purpose: to identify and prepare for existential threats to life on Earth. It is a coalition of the world's most powerful observatories, from NASA's Planetary Defense Coordination Office and the European Space Agency's Near-Earth Object Coordination Center to the sophisticated monitoring stations of China's Purple Mountain Observatory and JAXA's in Japan. For decades, its watchful eyes have scanned the heavens for asteroids and comets born within our own solar system, the local debris of our cosmic neighborhood. But in a closed-door session in late 2024, the IAWN issued a stunning, confidential directive. For the first time ever, its global network would begin concerted, continuous tracking of an interstellar object, 3I/ATLAS. The public reason, buried in technical jargon, was to refine astrometric models for hyperbolic trajectories. But the timing was everything. This announcement came just weeks after 3I/ATLAS had passed its perihelion, its closest approach to the sun, and had vanished into the solar glare. As it re-emerged, a handful of independent astronomers, using publicly available data from the Zwicky Transient Facility and Pan-STARRS, began reporting minute, almost ghostly discrepancies. The object was not where the orbital models, perfected over centuries of Newtonian and Einsteinian physics, insisted it must be. The math, for the first time, was failing. The first undeniable crack in reality came from a collaborative, decentralized group of astronomers and data scientists known as the Open Cosmos Initiative. They performed a simple yet devastating act of verification. They compared live, raw positional data from multiple telescopes against the predictions generated by NASA JPL's Horizon system, the gold standard for solar system dynamics. The result was not a minor error margin. 3I/ATLAS was over 1.5 million kilometers away from its predicted position, a distance equivalent to nearly 4 times the span between the Earth and the Moon. This was not a forward or backward drift along its path, the kind caused by cometary jets. This was a lateral shift, a movement perpendicular to its trajectory, as if it had taken a deliberate step to the side. In the language of orbital mechanics, this is heresy. A natural body, acted upon solely by gravity, cannot simply decide to move sideways. Such a maneuver requires an application of force, a thrust, and engine. Even the most spectacularly active comets, like the legendary Hale-Bopp, generate thrust only through asymmetric outgassing, which alters speed, not direction in this pure, lateral sense. 3I/ATLAS had executed a course correction. Naturally, the question arose, who knew and when? Attention turned, as it always does, to the giants of space exploration. NASA's Mars Reconnaissance Orbiter and the ESA's Trace Gas Orbiter had been in a perfect celestial alignment to capture high-resolution images of 3I/ATLAS during its close solar passage. These orbiters, equipped with cameras powerful enough to distinguish a coffee table on the Martian surface, should have obtained the most intimate portraits of this visitor ever seen. But those images were never released. Official channels cited ongoing calibration and data processing, a standard but thin excuse. Within the scientific community, whispers grew into conversations. Was this censorship born of caution or of something more profound? If those images revealed a geometry too sharp, a surface too uniform, or light signatures indicative of manufactured materials, the protocol for disclosure would be anything but standard. Adding to the mystery was the object's bizarre cometary behavior. Early observations noted it exhibited an anti-tail, a rare optical illusion where dust appears to point toward the sun. But after the Martian encounter window, this tail underwent a transformation. It didn't just change, it flipped, realigning itself away from the sun, as if the very source of its outgassing had physically reoriented the object. No natural comet has ever been observed to perform such a clean, deliberate reversal. Yet public statements continue to describe it as dynamic, but natural cometary activity. The dissonance was deafening. If it was so natural, why was the Global Asteroid Defense Network treating it like a priority target? By the beginning of 2025, the anomaly was no longer deniable. The positional discrepancy wasn't stabilizing, it was accelerating. Over a critical 48-hour observation window, the gap between prediction and reality widened by over 6 arc minutes, a colossal error in astronomical terms, translating to a lateral velocity of nearly 5 kilometers per second. To achieve this, 3I/ATLAS would have needed to generate sustained thrust equivalent to a high-efficiency ion engine, the kind used on probes like Dawn. The scientific community fractured into camps. The traditionalists argued for an exotic form of outgassing, perhaps from a subsurface reservoir of supervolatile ices we've never encountered. Others proposed interactions with the solar magnetic field, but the data was stubborn. Magnetic fields and solar winds don't push with that much focused directional force. The evidence was increasingly pointing towards a controlled propulsion system. Meanwhile, the IAWN quietly activated a seldom-used protocol, elevating 3I/ATLAS to a Tier 2 non-local anomaly, a classification that triggers enhanced tracking and data sharing between military and civilian space agencies. The most chilling part? The object's new trajectory still had it moving away from Earth. So why the heightened alert? The only logical conclusion was that the analysts were not afraid of its current path. They were afraid of its potential. They had seen that it could change, and they knew that if it could change once, it could change again. And then, it did. Just as the world's astronomical community was settling into a tense vigil, 3I/ATLAS performed a second maneuver. This was not another lateral shift. It was a refinement. Data from the Very Large Telescope in Chile and the Subaru Telescope in Hawaii detected a subtle but precise burn, a brief, calculated thrust that nudged the object back toward its original, pre-anomaly trajectory. It was a correction, the kind a spacecraft performs after a minor navigational error or a course-altering flyby. The movement was too symmetrical, too exact, to be the result of random venting. The IAWN's internal alert system flagged it as a pattern recognition event, Sigma 5, meaning its kinematic signature matched no known natural phenomenon in the database. Simultaneously, the European Space Operations Center in Darmstadt circulated an encrypted bulletin to its member states, confirming that 3I/ATLAS had exhibited non-gravitational acceleration inconsistent with any known cometary model. In plain language, it had fired a thruster. When Webb's NIRSpec instrument analyzed the event in mid-infrared, it captured a terrifyingly beautiful signature, a sharp 14-minute spike in thermal emission at 18 microns, a wavelength associated with rapid heat dissipation from a compact source, followed by an abrupt return to ambient temperature. It was the perfect thermal fingerprint of a controlled engine burn: ignition, sustained burn, and shutdown. The dam of official silence broke into a controlled panic. NASA immediately prioritized 3I/ATLAS for continuous monitoring across its deep space network. China retasked its massive fast radio telescope, the Sky Eye, to scan the object's vicinity for any form of electromagnetic emission, a task it normally reserves for searching for techno-signatures in deep space. The ESA placed its Planetary Defense Office on standby monitoring mode, a status typically reserved for objects with a non-zero impact probability within the next century. This was no longer about science, it was about reconnaissance. A joint team from Caltech and the University of Tokyo conducted a comparative analysis of the acceleration profile and thermal signature. Their findings, published in a private paper that was swiftly redacted, were eerie. The thrust-to-mass ratio and the specific impulse didn't match any chemical, nuclear thermal, or even advanced ion propulsion system theorized or built by humanity. Instead, it bore a haunting resemblance to a magnetoplasma-dynamic (MPD) thruster, a theoretical engine that uses Lorentz forces to accelerate a plasma to immense speeds, a technology we see as the holy grail for practical interstellar travel. And then the rotation. The object's previously stable spin began to modulate, not randomly, but in a precise repeating harmonic pattern with a primary period of 247 seconds. It wasn't tumbling, it was pulsing. It was, for all intents and purposes, broadcasting. The mission of the International Asteroid Warning Network transformed in real time. What began as a scientific collaboration was now operating as a global defense and intelligence task force. The new heading of 3I/ATLAS, post-correction, was the most alarming data point yet. It was not aimed into the blackness of interstellar space. Its path was now set on a long, arcing trajectory that would bring it into the gravitational sphere of Jupiter, the solar system's gravitational master. Projections showed that in less than 2 years, it would pass deep within the Jovian magnetosphere, a maelstrom of radiation and gravity powerful enough to tear moons apart. The coincidence was staggering. If this was intentional, the object was positioning itself for a gravity assist, a slingshot maneuver used by every space agency to save fuel and gain velocity. Was it using Jupiter to accelerate its departure? Or was it using it to brake, to slow down and stay within our stellar neighborhood? This was the moment NASA's Planetary Defense Coordination Office elevated the situation to a Level 3 dynamic contingency, a classification that implies an object's movements are active, intelligent, and its intentions are fundamentally unknown. And as this decision was made, a new faint signal began to appear in the data streams of radio telescopes worldwide. A low-frequency hum, a carrier wave, whose amplitude peaked in perfect, unwavering sync with the object's 247-second rotational pulse. The solar system itself seemed to be resonating with its presence. Then silence. In a window of less than 12 minutes, a global blackout occurred. Every major observatory tracking 3I/ATLAS, from Keck in Hawaii to the SALT in South Africa, experienced a simultaneous and total loss of telemetry. The Deep Space Network's feeds froze. China's FAST reported a blanket radio silence across the entire frequency band it was monitoring. It was as if a veil had been drawn across the sky. 47 minutes later, the data streams flickered back to life, as abruptly as they had died. The collective breath of the world's astronomers hitched. 3I/ATLAS was gone. It had not moved. It had vanished from its predicted coordinates entirely. It wasn't hidden behind a planet or the sun. It had simply ceased to be where it was supposed to be. All that remained was that same faint, low-frequency hum, still pulsing with metronomic precision every 247 seconds. Scientists initially dismissed it as a network system artifact, a ghost in the machine created by the blackout itself. But the signal was too clean, too perfect. It was a phantom echo, a heartbeat from an object that was no longer visibly there. The IAEWN classified the entire event under a new, previously unused designation: Interstellar Transient Anomaly, 2025 Alpha. One detail, however, was leaked by a source within the European Southern Observatory. In the final milliseconds before the blackout, an optical sensor in Chile had registered a single, coherent flash of Cherenkov radiation, a brief bluish light, oriented precisely along the object's last known velocity vector toward Jupiter. It hadn't been destroyed. It had, for lack of a better word, jumped. In the days that followed, a controlled chaos gripped the world's space institutions. The IAWN offered no public explanation. NASA held a press briefing to discuss routine system maintenance. Roscosmos was uncharacteristically quiet. The only official communication from China's National Space Science Center was a terse one-line update to an internal database. Tracking of Object 3I/ATLAS concluded. Target unobservable. For over a week, the object was a ghost. Then the James Webb Space Telescope, operating on a pre-programmed search pattern devised by a desperate team at the Space Telescope Science Institute, caught a break. It detected an impossibly faint glint, a speck of reflected sunlight moving at a velocity that defied belief, skirting the outer edges of Jupiter's orbit. When astrophysicists at JPL received the coordinates and ran them through their gravity simulators, the results were not just shocking, they were physically impossible. The object had not traveled the distance between its last known position and its new one. According to the laws of physics, it couldn't have. It had effectively teleported, performing what the analysts could only describe as a non-local quantum displacement, a change in position that appeared to be instantaneous, bypassing the space in between. The scientific community reeled. Theories of quantum tunneling on a macroscopic scale, warp field mechanics, and other concepts from the farthest edges of theoretical physics were suddenly on the table. Then, confirmation came from an unexpected source. The ESA's Gaia Observatory, a mission designed to map the Milky Way, detected an identical photometric flash at the new coordinates, exactly 247 seconds after Webb's detection. The pulse was the key. It wasn't just a signal, it was a locator beacon, and it was propagating through a medium we do not understand, using the fabric of space-time itself as a conduit. What happened next would redefine humanity's place in the cosmos. The IAWN's command center in Vienna received a priority, multi-encrypted data burst, marked with a classification level so high that only a handful of people on the planet had the clearance to view it. Level Omega. It was a data packet reconstructed from the corrupted streams of the 47-minute blackout. It contained no images, no telemetry. It was a stream of pure binary code, woven into the very carrier wave of the 247-second pulse. When the world's most powerful decryption algorithms, running on quantum computers at CERN, finally cracked its structure, they did not find a message of peace or a library of alien knowledge. They found coordinates. But these were not simple spatial coordinates. They were four-dimensional. The spatial components pointed to a specific point in the Earth's orbital path. The temporal component, the fourth dimension, was a timestamp. It pointed precisely 6 years and 17 days into the future. The initial assumption was a data corruption error, a cosmic ray bit flip. But as more of the transmission was decoded, a horrifying pattern emerged. The coordinates were not for a flyby. They defined a precise orbital insertion vector around Earth itself. 3I/ATLAS had not left our solar system. It had calculated a return. It had scheduled an arrival. The file was immediately sealed under the Asteroid Impact Hazard Scale's Level 10 protocol, a classification reserved for a certain civilization-ending event. Every agency involved issued absolute denials. Yet 3 months later, a university radio astronomy club in the Australian outback, using repurposed satellite dishes, began picking up the familiar 247-second pulse. Its point of origin was no longer near Jupiter. It was emanating from the heart of the asteroid belt, a region of chaotic gravity and countless hiding places. The signal was not fading into the distance. It was lying in wait, growing stronger. That was the moment the public face of cosmic monitoring went dark. The IAWN's live data feeds were severed. Open-source tracking websites were taken offline for maintenance. The global conversation about 3I/ATLAS was effectively silenced, but in the shadows a new unprecedented collaboration was born. A clandestine network of the world's most powerful private and governmental observatories, funded by a consortium of nations and tech billionaires, was established. Its existence is the world's worst-kept secret among the astrophysics elite. Its codename is Project Aegis. Its mission is singular: to track the evolution of 3I/ATLAS and prepare for its appointed rendezvous. Because we now understand that this object was never just passing through. It was a probe. Its initial maneuvers were not a malfunction. They were a systems check. Its interaction with the Sun and Jupiter was not a coincidence. It was a calibration, a study of our system's gravitational topography and energy resources. It was mapping our home with a patience and precision we can scarcely comprehend. It isn't fleeing, it is waiting. It is aligning. And now, if you know where to listen, you can still hear its heartbeat. Every 247 seconds, a whisper-thin pulse echoes through the solar system, a ghost in the machine of reality, a timer counting down to a day in the not-so-distant future. The world may have been told to look away, to forget, but the universe has a way of reminding us that we are not alone, and that the greatest discoveries are often the ones we are not prepared to make. So if you find yourself looking up at the night sky with a new sense of wonder and a tremor of apprehension, you are not wrong. Subscribe and stay vigilant. Because the story of 3I/ATLAS is not over. It has only just begun, and its final chapter is heading toward us, one silent pulse at a time.